of our series on environmental management 2027 to 2029 syllabus, which is the new syllabus. So here we're going to be looking at, still on natural resources, we're going to look at extraction of rocks, ores and minerals. So first, okay, what are ores? Your syllabus definition, you need to be able to define an ore as a rock containing minerals and metals. So that is what an ore is. It's a rock containing mineral and metals. That's all you need to know. Then we have, here are example of ores. We have a copper ore here, and we also have a gold ore. So this is how they look like. They contain rocks. These are rocks that contain minerals and ions and metals. Now, so what are the methods of extracting rocks, ore and minerals from the mines? So there are three different methods. This new syllabus added one more method to it. So first method is still the same, surface extraction of rocks and minerals, and the pattern involved in surface extraction are open cast, open pit, open cut and strip mining. Note, you don't really need to know the difference between them individually, but you should just be able to know that they are all examples of surface mining. Then we have the subsurface mining, which have to do with deep mining and shaft mining. So we'll look at past papers on this topic. So when we look at past papers, we will now look at some images that will differentiate between deep and shaft mining. Then we have biological extraction, which is newly included. These are the phytomining and the bioleaching method of mineral extraction. So we're going to start looking from the surface extraction. So surface mining, now it's a form of mining in which the soil and the rocks covering the mineral deposits are removed. The soil and the rock covering the mineral deposit are removed. So if you look at this image here, you try to explain it. Now you have the coal steam here, which is the mineral. The coal here represents the mineral. However, you have an overburden covering the mineral, and this is the topsoil. Now for you to assess it, you find that it's close to the surface, but for you to assess it, you have to remove this overburden. Then you get in contact with the mineral. Now usually this question comes with images. So they'll give you an image like this, and they will now ask you to identify which type of mining. So obviously you'll be able to know that it's a surface mining. So this can be an open cast or an open pit mine. Now, what are the steps? The steps involved in mining, involved in surface mining. The steps involved in surface mining. So there are 4 steps. The first step here is, if the mineral is located, you find where the mineral is being located. Now the first thing is for you to clear the vegetation. So the vegetation here has been removed. The vegetation is cleared and removed from the topsoil. Now after that, you need to remove the overburden. So the first step is vegetation is cleared and removed. The second step is that the rocks are broken and cut using explosives. So you use explosive to cut and break the rocks. Now that is like you removing the overburden so that you have access to the mineral that is beneath the overburden, beneath the rock. So once that is done, you now use diggers. Step 3, you use diggers, like you can see here. The diggers are used to remove the loose rocks, and you remove it and you put it into trucks, and trucks will carry it away to industries for processing. That's all. That's the first step you need to know for surface mining. It's as simple as that. You get your whole marks. Now, okay, there's no time to look at this. Now, subsurface extraction. This is done when the mineral is found deep beneath the earth surface. So when mining is carried out, when the rocks or ore and mineral are located at distant far beneath the ground to be extracted by surface mining. There are 2 methods which have deep and shaft. Now, in the sample paper for this syllabus, this image was there, which is an example of subsurface mining. Now, so what are the steps involved in subsurface mine? So here we have step 1 is the sinking of vertical shaft down to the rock containing the mineral. So that's the first thing. You sink a vertical shaft down to the rock that contains this mineral. After that, the step 2 is that a horizontal tunnel, this is the vertical. Now this is the horizontal here. A horizontal tunnel are dug down to the mineral layer. Once that is done, the loose rock are brought to the surface and piled up. Now using, you see here is the miner elevator and here is the coal elevator. So this coal elevator help to take the mineral out to the surface for it to now be transported away for use. So 2 things you need to know. 1, the first step is sinking vertical shaft down to the rock containing the mineral. So once you sink vertical, you now create horizontal tunnel are dug down to the mineral layer. Then the loose rock are brought up to the surface. You can say through the mineral elevator if you want to, but there's no really need. Just the loose rock are brought from the mine and piled up on the surface, and the mineral are being transported away for use. Now, last form of extraction is the biological extraction, and since the word here biology is here, biological extraction, so you should know that living organisms are involved. So this involves the use of living organisms. It involves the use of living organisms to extract rocks and minerals. That's it. Use of living organisms to extract rock and minerals. Now there are 2 types and you need to know them. Now, which are the phytomining and the bioleaching, sorry. Now, phytomining is using plants to extract mineral, while bioleaching is using bacteria to extract minerals. Now, what are the steps involved? Just know the steps. You don't need to stress yourself. Just know this process and this other process. So if you are asked to describe how phytomining are used to extract minerals, simple. You know it's plant. How is it done? So you grow plants on the soil that contain the mineral. So once you do that, the next thing is that the plant, as it grows, it will now absorb the mineral through their roots. Now, once that is done, you harvest the plant after they are grown, then you burn the plant to produce ash. Now, the ash from the plant contain the mineral. Then the next thing you need to do is to extract the mineral from the ash. That's all. First, plant. The plant will absorb the mineral. Once the plant is grown, harvest it, burn it, produce ash, then extract the mineral from the ash. That's all about phytomining. Then in the case of bioleaching, is the use of bacteria to extract metals. So you find out that you add special bacteria to the rock containing the mineral. The bacteria will now feed on the mineral, help to break them down, and then releasing the metal into a solution. So you should know first bacteria, 2 bacteria feed, then bacteria excrete or release the metal into a solution. So now the metal-rich solution is collected and you extract the metal from the solution. That's all about bioleaching. Now I have a simple diagram here explaining the phytomining process. So you see, this is a low-grade copper ore. You plant, the plants absorb the mineral, then you burn the plant, you produce ash, then you extract it from the ash. Now, what are the factors? This will take us to factors that affect the decision to extract rocks, ores, and minerals. So before any mineral is being extracted, you need to you need to make a decision whether you should do it or not. Now, this major reason for these decisions is to know the impact on the environment and also to find out if it is profitable for you to carry out such extraction of that mineral, if it is economically viable, if it's economically needed, if there is a market for it. So the first thing you need to consider is exploration. The first factor is exploration. Now, exploration is the decision. The decision depends on whether exploration show that there are valuable minerals or rocks that are present in the area. So you first do an exploration of the area. You first check the area to know if there are viable minerals. Then 2 is the geology. The geology simply means the type of rock and structure of the land. It determines how easily the mineral can be found and extracted. So the geology will help you to know if you should carry out surface mining, if you should carry out subsurface mining, or if you should do the biological extraction method of bioleaching and phytomining. So the geology of the area will also help you to make such an informed decision. Then next is availability, accessibility and terrain. So extraction is easier and cheaper in flat land because it's easily accessible with your diggers, with your trucks, even your workers. It's easily accessible than that of mountainous region. Now you should also look at the quantity and quality of the deposit. So you look at the ore. Remember, the ore is a deposit of either rocks that contain minerals and metals. So you check if it is a high quality and large deposit, you know it will be more profitable and therefore there will be need for you to extract it. But if it is of low quality or it has a low grade ore, then you might decide not to extract it because you will not make much profit from it. Now you need to carry out an EIA assessment, the environmental impact assessment. Now you find that the mining may be stopped or limited if it causes serious harm to the environment or the local community. So you must take an assess of that before you decide if you should continue with the mining process. Then climate of an area. So extreme climates such as cold or wet condition can make mining operation really difficult. So it will really expose both the workers within that area to certain hazards. Then we'll now look at supply and demand. Supply and demand. So if global demand and prices are high, then mining becomes more attractive and profitable. So you need to look at the supply and demand nature. Then next is the cost and profit. So extraction will only occur if the value of the mineral is greater than the total cost of mining and processing. Very important. So extraction will only occur if the value of the minerals is greater than the total cost of mining and processing of such mineral. So that's it. So next before the last one, this 1.2 is quite bulky. So we need to also look at the impact of rock and mineral extraction. So impact here can be positive and also negative. So anytime you hear impact, it includes both positive and negative impact of extracting rock and minerals. First, here we can look at it lead to loss of habitat and vegetation. Remember, we say in the first step for like surface mining is to clear the vegetation. So when you clear vegetation, what you do is that it will lead to loss of habitat and also the biodiversity, the different organisms that are found within that environment. Now, mining can lead to air, land, water, noise, and visual pollution. Remember, we say you use explosive to break the overburdened rocks. That can lead to noise pollution. Now, the extraction uses machines. These machines can release waste into water bodies. Then waste heap can lead to land pollution. Visual, the area will no longer have the scenic beauty that it should have or it has initially. Then dust particle can easily be released into the atmosphere, and all these can cause air pollution. Now, water usage also is another impact. So we've looked at 1, 2 impact, 3. So a lot of water is used in the mining process, especially for minerals like gold, where you use gold panning and the rest. So you find out that the water can be polluted and in that process, and where you use a lot of water also, such as in case of when you are doing fracking, which we'll look at later, you find out that a lot of water is used. So the water, it can lead to water scarcity and poor water supply within the local environment. So waste management also is an issue. You have to find how you manage the waste generated from mine. So that's an impact. Then lastly, we have changes in employment opportunities. So it creates jobs for both the local community, which help to improve their living standard. Another importance is that it helps to improve both the local and national economy. So revenue generation from mine, this will help to increase the GDP of the economy. The local economy will have more jobs. You find out that they will earn more money from export. So, and also infrastructure development such as schools, such as roads, you have better hospitals, can be done based from the money you derive from selling this product by the government. So they can use that to develop the economy and the infrastructure within that locality. Then lastly, we need to look at the strategies for managing landscape damaged by extracting rocks, minerals, including their benefits and limitations. So we need to also know the benefits and limitation of these mining methods, of this managing methods. So there are two things your syllabus also need you to know on how you can manage landscape. Remember, the landscape is being damaged during the process of mining because the open pits, it creates the pits, the subsurface mining, it can also lead to spillage of oil and the rest. So how do you reclaim this land so that it will now still be useful? So the first thing here is land restoration. You should restore the land. How do you restore the land? You do that by replacement of overburden, soil improvement, bioremediation, tree planting. Then the second method of managing the landscape damage by extraction is repurposing the land. That means let the land be used for something else. You are repurposing the function of the land. So you can use it as a landfill site, you can use it as convert it to a lake, you can convert it to a recreational center or a nature reserve. Sometimes you can even convert it to a golf course, you can convert it to a stadium, whichever. You can convert it to an estate where people live. So you find out that land restoration, what does it mean? It means restoring land. Restoring land means repairing the landscape after mining to make it safe, stable, and productive again. Now, so under land restoration, remember the first thing is replacement of overburden. What is the description? It has to do with waste rocks and soil are replaced to fill pits and reshape the land. It has benefit and limitations. So soil improvement simply means adding topsoil, compost, or fertilizer to improve fertility. Then bioremediation means using microorganism. Take note of this definition. It means using microorganism or plant to remove toxins and pollutants from soil and water. Then we have tree planting, which has to do with planting native trees and vegetation to restore ecosystem. Now, both you can actually pause this video here to look at their individual benefits and limitation of way of managing the land after exploration has been done. Then next is repurposing the land. Repurposing means converting former mining site into useful new purposes once extraction stops. So we can convert it to landfill site, lakes or water reservoirs, recreation centers. We can convert it to nature reserve. So you can also pause this, look at their description, the benefits and limitations. So we are done with syllabus content 1.2. So next lesson, lesson 3, we are going to look at sustainable management of rocks, oil, and whatever, ores and minerals. So have a nice day.